So today we're going to be walking the scale model of the distance between the planets in my backyard. The sun is here, and then all the way down there by my kid's swing set is the middle of what we call the Kuiper Belt, where comets come from. We're going to be measuring in what's called AU, which is an astronomical unit. 1 astronomical unit is the distance from the sun to the Earth, which is this stake right here. So 1 AU equals 93 million miles, or 150 million kilometers. So I scaled my model so that 1 AU equals 1 meter. So my model is a scale model of just the distances from one planet to the end of the solar system, which we're going to go to the middle of the Kuiper Belt, which is 40 meters all the way down there by the swing set. So let's walk it out. Here's the sun. And then the inner solar system is composed of Mercury, Venus, Earth, and Mars, all of which are what we call our rocky or terrestrial planets. You'll notice that the inner planets are very close together or close to the sun. Mercury, Venus, Earth, and then a little bit further is Mars, which in this scale model encompasses 1.5 meters. So now on to what we call the outer solar system, which is our gas giant. So we're going to walk it out to Jupiter, which is much further from the sun than any of the other planets. Between Jupiter and Mars, though, however, we have something called the asteroid belt. And the asteroid belt is where larger bodies of rock come from. They never made it together to sort of make a planet. That's one theory of why we have the asteroid belt, is it's all the pieces that would have made a planet. However, it failed to form during our solar system formation. So if we stand down here at Jupiter, you'll notice that the sun is all the way at the edge of the road. So it should look tiny from being on Jupiter. So now we're going to leave Jupiter and we're going to head on out to Saturn, which is a planet with all those rings that most students know about. It's a very large planet, not as large as Jupiter, but it has those beautiful rings. And so Saturn's right here. So again, if we look at Saturn to the sun, it's pretty far away. So as we leave Saturn, which is 9.2 meters from the sun, we're going to head on to Uranus, which is a little over 19 meters from the sun. So here would be what we call Uranus or Uranus, depending on how you like to pronounce it. And again, if you look down my yard, it's really sort of hard to see where the sun would be from Uranus. If we lived on Uranus, which is also a gas giant, we would see only a tiny sort of bright light in the sky. It wouldn't quite look like what we see here on Earth. So Neptune is 30 AU, or 30 meters in our scale model from the sun. So we're going to walk it out. And here is Neptune. Now we did walk downhill a little bit because my yard is not perfect. So if you were to sort of look from here to the sun again for Neptune scale, we would see sort of just this much smaller dot than we would have seen on Uranus in Neptune. Now we're not going to go to Pluto because it's no longer considered a planet. However, we'll go to what's the middle of the Kuiper Belt will be our next stop. So here's Neptune, and then we're going to walk it out to the Kuiper Belt, which is another 10 meters from Neptune. So a total of 40 meters, or what we call 40 astronomical units from the sun. And this is the middle of what's called the Kuiper Belt. And the Kuiper Belt is where cold objects come from. So this is where our comets come from. They have a highly elliptical orbit that they come in and shoot right around the sun and back out to the Kuiper Belt. So this is where our comets come from. They have beautiful tails once they reach the sun because they're just chunks of ice and dust. So as that ice and dust interact with heat from the sun, it makes those beautiful tails that we can see in the sky. So, that is our walk from the middle of the Kuiper Belt to the sun, or from the sun to the Kuiper Belt, which is a total of 40 astronomical units. Again, an astronomical unit is 93 million miles, 150 million kilometers, or the distance from the sun to the earth. It's just another way to measure large distances in space. Scale models are great so that we can understand where objects are in space and to see how vast or how wide space is.